Let's move into simplifying radical expressions using two very popular rules, the product rule and the quotient rule. The product rule basically states that as long as our indices are the same and we're multiplying two radical expressions, we can multiply the radicands together under the same radical. This also applies in being able to simplify, where we can actually break apart the factors of a radicand into two separate radical expressions under the same index. This is basically the same relationship we saw earlier, where we have the same exponent and we can multiply the bases together with the common exponent. This allows us to simplify our expressions even further. So when we have the square root of 3 times the square root of 5, we simply just take the square root of 3 times 5 under the same radical. This gives us the square root of 15. If we're left with a radical that we can simplify, we would do so. Otherwise, we leave it in its exact notation unless rounding is specified. Square root of 21 times x, square root of 21 times x, which just leaves us square root of 21x. We have the same index even though it's third root, so we get the third root of 4 times 2, which gives us third root of 8. Now third root of 8 is a perfect cube, so we can get 2 as our final answer. We have fourth root, same radical, 5y squared times 2x cubed. We'll go ahead and multiply the integers, leaving us with 10x cubed y squared. Radical of 5 over m times t over 2. We multiply our numerators, and we multiply our denominators. Quotient rule is very similar. If we have a fraction within our radical, we can write it as two separate radicals with a numerator and denominator. It also means that we can simplify by combining them into a single radical expression, whichever is most beneficial for simplifying. We've done problems like this before, but it's easier to visualize when we consider our quotient rule. We can take the square root of the numerator and the denominator separately, giving us 5 over 7. Now where this property really shines is when one part of our fraction we can take the root, but the other part we cannot. So we have the square root of x over the square root of 9. I can't simplify the square root of x, but I can take the square root of 9. Even if we have other indices, cube root, they'll both have a cube root for their index, meaning we can take the cube root of 8 and the cube root of 3, or 27. And here we have the fourth root of 3 over the fourth root of 16y to the fourth. I have to leave the fourth root of 3 alone. But here we're actually applying our product rule, and we're taking the fourth root of 16 and the fourth root of y to the fourth, giving us fourth root of 3 over 2y to the fourth. Or I'm sorry, 2y.